I've constructed this presentation so that you can follow along on your laptop. And it's like, with this button, it's a that button, you do this, do that. However, if you don't want to go there, you keep that, knowing that this presentation will be available with slide deck. So you need to decide, how you want to approach it. I'll be quite honest, I find it very hard to follow on a laptop through the swamp. KiCad is the thing that about KiCad is keep getting ready, keep getting ready. Then when we get to the PCB part, they kind of boot, you're out the door. And so all of it is really the early prep. And so that's what we're gonna go through this, go through this. If you have questions, hopefully when you get finished, you'll understand the KiCad. Okay, I'm using the word KiCad. You might heard it, KiCad. I'm not sure which way is the correct way.
I can state the correct way because I looked up a video by the project manager of the project, and he pronounced KiCad.
You think KiCad? That's good, because I don't like to say it. So, that's good. Okay, so now, all right. So, buckle up. We're going to start. Okay, first thing is if you haven't got it, this is based on version 8. Okay? Well, you know what would happen? In this last week, they have released version 9. Okay?
I was afraid of that because I saw like February of last year.
There's going to be, version 9 is going to be better, but everything in this will be pertinent. And you can imagine, like any new version, there's always few things that don't work. And there's a few little tricks that won't work, but overall, it won't be any different. But if you want to get the exact version that's on this, it's 8.09. Okay, this is the last version of all right. So what are we going to do?
So, Doug, are you going to share your slides out to join? Are you going to join the?
Yeah. If you want to, this would probably be a good thing for some of you to do. Is if you go out right now, this will not be there forever, but for right now, if you go out, DPRG or.
Well, the reason I'm asking is the slides will end up in the recording if you put them.
But if you go here, this is important because you might want to do this while you're getting here. This isn't killing until
That's right.
Go to DPRG.org. Everybody who does it who's doing it. Click on the KiCad for robot. And if you slide down to the bottom, you'll see there's 2 links, 0.1 and 0.3. Okay, 0.3 is a partial and 0.1 is the complete project. So you probably want to start with 0.3 and download that if you're going to follow on your laptop. Okay, but you can start with a new one. Create a new project if you want to get going with and follow along. So we'll see how this is. All right. All right. All right, so here's what we're going to cover. There are four present parts of the presentation. We're going to do a little bit about the KiCad interface. We're going to build a schematic. We're going to how to lay out a PCB, and then you're going to get a PCB build and JLP PCB. Okay. Our example PCB is going to be a modular motherboard. What do I mean by a modular motherboard? Okay, there's so many small, cheap, easy to use electronic motherboards, but that's generally how we build both functionality for the website. So, for example,
Can I interrupt? Because Ray is reporting that the audio is muddled, which means it'll be muddled for the recording. John, do you have the Lavalier mics in the meeting here?
okay, just in the meeting now, go back at 3 o'clock. Very hard.
If this is parallel. Yeah, I've got the base station here. Not sure which one is which. Oops. Let's say USB-C. Damn it. This is yeah, yeah, there's two different units here, so I think this one might work better than try. Thank you. Thank you. Hello, hello. Can you? All right. Oh, that was something over and you try it. That might work better. This isn't showing up. Greg, can you talk and I'll get a report from
Okay,
Ray.
this is how the presentation will go. This is typical talking. Can you hear me?
Yep, it's much better.
Okay. Thank you. I just had to select the microphone in the camera.
Okay, gotcha.
Okay, thank you, Ray.
All right.
Sorry about that.
No, that's fine.
Go ahead.
Okay. All right. So, like I was saying, nowadays, when we build a module, instead of using ICs and whatnot, we actually use modules. For example, if you're making an ESP32 robot, you're probably not going to use an ESP32 module. You're going to use the ESP32 Develop Kit version 1, 2, or 3. Okay, because it's done to the manufacturer's spec design, and it's easier. All right. So that's what we're going to do. So what we're really doing is building a PC that's a motherboard where everything gets glued to the PC through connectors. Okay. And I'm going to show you how that works. And now if you don't do it that way, if you just build it with the individual modules, it gets to be a really nasty wiring mess. And this allows you to organize your wiring a lot into a lot neater package. So it is a very valid thing. Now, all the techniques, this is a KiCad tutorial. So everything we're doing, it's not really what PCB we're going to make. It's really how do you make the PCB. So you're going to be able to use anything we talk about today will be able to be used for any PCB. All right. Okay. If you've got a laptop, open up KiCad. And this should be what you see when you first start. Okay. Now, the real guts of KiCad are those first four icons. And if we look at it, it's kind of a yin-yang thing. Okay, there is a schematic editor where we build a schematic. There's a PCB editor where we build the PC. Okay, but if you notice, there's four things there. One of them is a symbol editor, and one is a footprint editor. So the symbols, or the objects that you put in the schematic, are called symbols, and they're created by the symbol editor. And the things that you place onto the PCB are called footprints, and they are put in with the footprint editor. So those are the four things. Now there's some other things that we want to look. If you go down to the bottom, you'll see there's a plugin and content manager. All right. We want to select that. Let's see what happens when I click down. Did that get rid of the presentation?
No, presentation is still showing.
Okay, so let's see, how do I do this? I may actually have to, maybe I do this. No. Okay, let's see if we do this, see if this happens. Now, do you see the KiCad?
No.
Okay.
You need to mirror your screen. Oh, now we do.
Oh, there we go.
Okay. So now here, this is going to be a little bit of a pain because I got to show you the presentation, and I also got to show you KiCad. All right. So let's close this off. And so here's where you are right now. You got nothing. So you want to go to the file, and you're going to want to create a new project. Okay.
Do we want to install those plugins or not?
Oh, okay. Yeah, thank you. Let's look at the plugins. So go to the plugins. And you see they're in the plugin section. First one we want to do, if I can find it. Oh, and when you scroll down, look at what's available. There's a few things. Like if you're in PCB Way, there's a plugin that is actually coordinated with KiCad and it goes right in. But even though that could be potentially easier, it's also potentially more expensive. And I would still go with JLC PCB. It's a minor difference on how to do it. Sliding down some more. Ah, there it is. So we want to install that. Now you notice it says install pending. Well, that's because it's going to allow you to stretch down. Now I also recommend, though we're not going to use it in this one, there's the GitHub. There it is, the Git plugin. So that one ought to probably also be installed.
What was the first one you looked at?
First one is free routing. And let's see where I can always, there it is. It looks like a circle with little PCB. And then you can apply the pending changes down here. And I'm going to download this and put that. All right. And it's closed. Okay. And that's actually going to put two icons onto one of your editors, and we'll talk about that when we get to it, okay? So for you guys, what I recommended was to go ahead, if you just want to follow along, is to create a new project and go to
It's not very top secret now. It's a top secret of the director thing.
okay. So we want to go. I want to go to. So create a directory in your called KiCad projects. That's the easy way to do it. And then put a new folder. And the new folder we're gonna call it top secret robot project. Okay. Now, once you open that up, this is to get started. I recommend that you create some subdirectories in this directory. So go up here, and one of them will be footprints. I've just got eye surgery, guys, so you got to give me a little bit of footprints. Okay, and then another one, we're going to call it symbols. Okay. If I can spell it right. Symbols. And then another folder, we're going to call this project. Okay. And another folder, we're going to call it 3D models. Okay. Some of our footprints will have 3D models so that you can view a PC board as a 3D thing. Okay. So this is just getting set up, guys. All right. So now we're going to go into the project, and this is where we're going to call it secret robot project. Okay, and we're going to save that. And okay, and you can see right now we have it generated a KiCad PCB and a KiCad underscore SCH, which stands for schematics. All right, so let's go back to the presentation. And all right. So I believe this is kind of where we are. Okay. Now, when you save it, you'll generate an additions project, which will be the KiCad underscore PRO. Okay. All right. You can see I said create 3 subdirectories and then gave you 4 to create. So that's a typo. All right. And let's go to the next one. So I want you to open up the schematic screen. Okay. When you open the schematic screen, it should look like this. And down in the bottom, you should see a title block. Does everybody who's following along see that? Okay. Now, if you click into the file name of that title block, it should pop up. It should pop up how you can edit it. Does everybody see that? In the center of this, so let's see. you should see, if you're successful, you should see something that looks like this. Okay, this gives you the fields that you can adjust in there. Now, there's another way to get it, which is probably what I told you was a shortcut. Another way you can do it is to go to Edit. It's under schematic settings. So can anybody tell me what's if you go into file, file. If you go into file, open the file. And slide down the right sub tabs. There's one that's called schematic settings. What's the one underneath
Page
that?
settings.
Huh?
Page settings.
Okay. If you hit the page setting, you'll see the same block. So there's two ways you can get to there. I think the one I just told you is the way they probably anticipated you. The first way I told you is actually a shortcut. All right. Now, the one thing you should probably do here in the United States is go ahead and change the page size from A3 to letter. Okay. Okay. Everybody with me so far? And we're going to slide to the next one. All right. Okay. When you go into the schematic page, okay, schematic sheet, you've got the schematic sheet up. All right. You'll notice on the right side of the thing, there's a lot of icons. All right. We're going to kind of slide down those icons as to what's important and what's good to know, but not quite immediately important. Okay. The first one, the one that's selected, is select. That's obviously very important. Okay. The next one, highlight nets, is useful, but not necessarily what I'd call important. The next one is add symbols. This is the one we use to actually put a symbol onto the page. So that's the add symbol one. Now, the one that looks like a ground symbol, that is actually the power symbol. Things like VCC and ground are considered power sources, and they're treated differently than an add symbol. Okay, so you need to know that. That's important. And then under that is add wire, which that's what we're doing. We're adding wires, so that's going to definitely be important. Underneath that is add bus. You can take a group of wires and turn them into a bus, but we don't need to worry about that in general on our projects. Okay, and then the next one down is the add no connect flag. When you have a pin that's not connected, all right, you have to mark it as not connected. And the reason for that is the ERC is going to expect it to go somewhere. And if you don't have it connected as non-connected, now nobody can call me out on that.
ERC.
Yeah, there is a man. Okay, electrical
rules check.
Thank you. Electrical rule check. Okay, so that's one of the goals and one of the strengths of using a program like KiCad is that you can have it. How many of you have ever built a handmade project where you wired point to point? How many people have done that? Okay. How many of you have made a wiring mistake? Okay. All right. So the thing that helps, that makes these things, makes these programs like KiCad so important, so useful, is wiring mistakes, if you have a good schematic, are a thing of the past.
So I'll ask the question. How many of you have ever had a PCB fab and it had a wiring mistake?
Okay. But now, did you do it because you had an error in your ERC, or did you do it because you had a schematic mistake?
A bonehead.
Oh, yeah, that's usually That, and then when you make PCBs, putting a footprint,
Yeah.
that's the other biggie. But we won't go there yet. All right, so going down here, adding labels. All right, when you have a wire, you tend to it's a wire, you want to label it. All right, because we're going to want to group certain labels together into net classes, and we'll talk about that later. All right, so there's essentially three types of net. There's one where you put it just on an individual wire. There's one where it's called a net class directive, which is when you assign a net to a net class. And then the final one is a global label. And the global label is good everywhere. And we'll talk about it because you can think of these in a sense like, oh, and there's one more, hierarchical label. And that's used when you have a multi-page or a multi-sheet. And a sheet can be on one page, but we'll not talk about that. We won't talk about hierarchical projects right now, but it's definitely worth it. I'm sure you've all seen a schematic where they have the power supply up in the corner. They have the microprocessor separated. They have something over here. They have something down here and something over here. That could be a hierarchical data sheet, and they're useful, but we're not going to cover it in this introduction for us. Okay. Oh, and adding text. If you want to leave a comment on your schematic that you just want to say, you really need to make sure that this is a 3-watt resistor or something like that, you can make a comment on it. Okay. Or actually on your website.
What's the difference between a label on a net class, and a global?
A global is basically a label. So,
Or maybe an example.
Think of it as where you're tying things together. Wait until we get a little bit further.
Sorry.
I think that'll be.
Sorry.
Okay. Okay. So anyway, these are all on the right side. Okay. So now let's define what a symbol is. Okay. Okay. A transistor. You can see the schematic transistor symbol. The next one is a resistor symbol. The next one is a capacitor symbol. The next one is a microprocessor symbol. The next one is a module symbol, which is the Nano Arduino. And you all know that the Nano is not just a Atmel 320/28P. It's got all sorts of stuff on it. So it's an actual module. And that's what we're generally working with, is modules. But sometimes, because the people in China can generate new modules faster than they can generate symbols for us. So you often end up having to make a custom module. Now, a custom module symbol is really not a problem, okay? Because, well, let's see where we would do this. Okay, our project is going to use the TB6622 FNA dual motor driver. This is what the chip looks like. This is the top side. This is the bottom side. This is the pinout. Okay, that's what we're going to do. It turns out we looked on the net, and we didn't find a symbol for it. Now, actually, you can look on the net, and you can't find a symbol. But we're going to make our own symbol because we don't like the symbol that's on the net, on the internet. All right. So here is the next. Here's a tool that makes this generating symbols for this type of for modules, or even ICs, or anything, very easy. Is go to this link. I want you to open it up right now because we're going to build a symbol. Everybody got moving along? Okay, so has everybody got this guy up?
No, hang on.
Now, you might get, depending, there's one thing that I wish they would fix. You see it's an HTTP site. So some browsers are gonna be very upset with this. All right, but hopefully your browser will open it up. We got it?
I get a Microsoft sign-in prompt when I click that link. Anybody else get that?
You got a what?
A link to sign into Microsoft Online.
You should have to do that.
No, I didn't.
Yeah. I guess the question is, are you using Linux by any chance?
No, I'm on Windows.
Okay, so you're signed into your Windows account?
No, I'm not.
Okay, that's the reason why. Yeah, you gotta be, it probably says you have to be signed into your Windows account.
I don't know why that is.
I don't know. If you're worried about things like, does somebody have my email? I got news for you, Jack. Your email is in there. You might as well not worry about that. Okay. Okay, so if you've been, any luck?
No, but I'll get there.
Okay. All right, so let's look at this. If you look at it, I've got four things circled. Those are the most common things that you've got to change. Okay. The first one is the name of your module or your component. So we're going to put it in as TV 6612 dual motor drive. Okay. The second thing is how many pins does it have?
So should mine come up with the exact same settings as you got here?
No, I think they'll be blank. You got to put it where I have the red things. You got to enter something.
Thank you.
Okay. Now, actually, 3 is a selection. So you can see that on the bottom there, after you have the number of pins, there's different configurations. You can have pins on the left. You can have pins on the right. You can have mixed pins on both, equal pins on both sides, which is the DIL, and that's the one we're going to be using. You can have pins all around the thing. I don't know what you do with that.
All grid.
All grid one, but let's whatever. Okay, so you can have all of these things different ways. In actuality, I've only ever used the first 2. Okay. Now, and you'll find out that even that is not cast in steel, cast in iron. We're going to find that you can change that. All right. So has everybody put 16 in there and picked the deal and clicked on the whatever it is?
The sign pins.
Yeah, sign pins. All right. So now we're going to put these pins. I want you to write those pins in. All right. Now, where did these pins come from? Does anybody know? Am I just pulling these 16 pin names out of my? No, it's actually from that slide where I showed you the 6612. Does anybody want me to go back there, or do you want to stay here for a while? Believe me, I got it. Yeah, I think I got this part right. Okay. When you get ready to go to the number 2 box, tell me. Give me an indication that you're there. Yes.
Where can I find the presentation?
I'm sorry?
Where can I find the presentation?
The presentation right now isn't available on the web. Well, actually, it might be. If you go to that DPRG page that I told you and download 01, okay, I believe it's in there. Oh, man, I thought I was a slow typer.
So, but we're trying to make everything like including the pen type, right?
Okay, well, I was gonna, okay, go ahead and do that. But we're gonna talk about pen type, all right? But you can see that there is pen types. Now, if you drop down one of those types, you'll see that there's, I think it's input, output, passive, bidirectional, power input, power output. There's probably a couple of this. Okay, so these, if you look at them, if you think of them, VN, or V motor, VM is the motor input. So that's definitely a power input. VCC is a power input. The next one, ground, might be a little tricky because we tend, or at least I don't, never thought about it, but ground is always a power input. Okay, so that's one thing to know. Ground is always a power input. Now the next ones are AO1, which is A motor output 1, and A motor output 2. They're both outputs. And the next one I think is BO1, BO1, BO2.
They're flipped.
And those are both going to be outputs. And the next one's a couple of ground pins, they're power inputs. And then, I can't read it.
PWMB.
PWM is this motor driver uses 3 pins to set motor, 2 to set direction, and 1 to do the actual PWM on this particular module. So all of those are just inputs. And so that's the rest of them, I think. That's for the 2 different motors. AIN1 is A motor input 1. It doesn't actually go to the motor, but it's the motor channel, if you want to think. The A channel and the B channel, because it's a dual channel motor driver. So that's how. Now, why did we even mess with those pin types? Well, we're going to talk about that in a little bit, but they're important. All right. So now, everybody ready for 3? Okay. Now, if you hit 3, it generates and lets you download a ping file of the module you're going to create. It hasn't created the module, but it'll allow you to download it. Okay. Now, pin 4 is where we actually want. So in theory, what you would do is you'd preview it, you'd look at it, see if you got it right to match what you think you're going to want. Then you go ahead and do the build. Now, one of the problems that you could run into is that you're writing, these are all pretty short, but what if it was something like, this pin is really big and I got to call a number 7647,000, it makes a big long text. And when that goes into your symbol, it takes more space, so you have to increase it by changing this value up here. Okay, but in general, for most modules, you won't have to do it. So when you're ready, click that. And it should go into your, you'll ask you where to put it. You want to put it in your project symbol directory. And you should see something, you could see something like this. Unconfirmed, see something download. Okay, what's going on there? That's where that HTTP is catching you. And you have to go over in Chrome, you have to drop your take the download button, drop it. And if you see the word keep, click on the word keep, and then you'll see it in your symbols directory.
Firefox doesn't.
Desktop. Okay, good. All right. So just anyway, so now if you go to your symbol directory, if you open up that folder, you now see that promoter driver.lib. Okay. Now, this is an older format of libraries that KiCad uses. It's much simpler. It's a text file. You can understand it. You could even modify it if you wanted to. But they've now created, they use a KiCad _symbol SYM file now. It's more complex, but KiCad will take the lib file because there's so much legacy out there. All right, so let's talk about pin settings. So here's your types of pin types. So I didn't think of tri-state, unspecified. I'm really not sure what unspecified is. And open collector, oh, wait a minute. Unspecified, if you leave a pin unspecified, it means that KiCad is going to complain to you later. It's really saying, I don't know what this is, and I'm going to fix it later. So like if you went in and just wrote unspecified, 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 somewhere along the line, it's going to require you to go ahead and to put them into real pin types. So it's sort of like a pin type holder. I've never used it. Okay. There are power outputs, and we'll talk about that. Power input can only be fed by a power output. There's open collectors. That's a type of pin output. And open emitter is another type of pin output. If you don't know what they are, don't worry about them. You're not gonna, probably won't need them in most of them. Okay, so ready? Now, okay, setting pin type is to make ERC as useful as possible. That's why you're doing it. Okay, and you ask, well, I don't know anything about this module. How do I find this out? Well, if you go to the data sheets, and a good data sheet I really like is the VNO 055 or 085. They list it all. They obviously, somebody there was thinking. But here it's more typical. You can see this from the VN 6612. So it says the A output 1 and A output 2. Okay, the reason why they have two A01s and two A02s on this pin, on this mod, because this is the chip. This is not the module. This is the chip. And on the chip, to dissipate heat, the output pins are actually carried over to 2 pins. Okay, but you can see it labels them as outputs. The next one is ground, power ground. Well, we know that ground is always a power input. Okay, so the ones he's using dash are going to be power pins. And you can see where he has BN. Well, anyway, you can see they're called inputs. And so that's where you would get a clue of how to set these things. Okay. Now, I'm going to show you this. Don't freak out. Don't try to read it. This is for reference. This is for you to look at later. This is a gentleman, Renee, and I want to say it's Osh, but I'm not sure that's how he pronounces it. This is the link, and he has a very good article talking about pin types. And this is a lot of that information, but don't worry about it. This is here for reference only. Okay, now I got this symbol and it's in my symbol directory. How do I get it into KiCad? Well, we're going to create a project symbol library. Okay. Now this is where we're going to put all the symbols that KiCad doesn't have. So how we're going to do it is we're going to go up here to the symbol editor. This is on the schematic page. Okay, if you click on that, you should see this box right here. Everybody got that? All right, so now what we want to do is going up to the file over here, we're going to hit new library when it drops down. And this little box is going to pop up. And we're going to select project and hit OK. All right, now that we're going to go to our project directory and we're going to name this. I'm sorry, I can't read what I wrote. What does it say there? Name it whatever you want. I usually name it something like the project name.
Secret robot proj .kicad._sim.
Okay, all right. Well, I think, yeah, it may put that in there for you. I'm not sure. When you name the library and you click, now back in the symbol editor. You back in the symbol editor. If you go to the search part and start writing out things. So if you put in secret, if you did it to what's on this one, you should see a library pop up. Okay, now if you click this drop down, you'll see there's nothing in it. But you created the library. So you've got the library. Now we're going to put stuff in the library. All right. Everybody ready for me to pop to the next one? Okay. All right. So in the symbol library, you go down to import symbol and hit enter. And then you go to your symbol directories, click on the one we just created, and then you hit open. Okay. When you do that, you should see the symbol drop into the symbol library drop-down box. Should be there now. But you'll see it has a star. Okay. And if you exit out of here now, you didn't save it. You've got to save it. And when you save it, it'll look like this. Okay, so let's kind of review what we did here. We had a module we didn't have any symbol for. We created the symbol. We created a library to put the symbol in, and we put the symbol in the library. These are all key skills for you when you're building our actual board, because we won't have symbols for everything. Okay? So now we're gonna have a little reward. If you did all of this, you guys got this all done? Okay. Well, I want you to go on the schematic sheet and click the add symbol icon over here. And okay, and when that happens to pop up, I want you to click onto that library symbol we just put in our library and place it on the board. Now, there's a couple of things here we can look at. First of all, you can see the symbol that you created, and when you put it on the board, you'll see it again. Okay, so there you go. So now not only have you created a symbol, put it in a library, you've actually used it. Okay? All right. All right. Now, you guys look like you're doing actually very good, guys. You've actually, I think some of you actually are where I am. So we're going to do that. You're going to get rewarded. You get a symbol exercise. So I want you to use the symbol you want to use. So let's go back. Just to make sure you understand that, you got to click the add symbol directory right here. And go find these symbols and stick them on there. If you get one or two, that's good. I just want to just make sure you kind of got the idea.
So are they in just any LED?
Well,
Should there be one called LED?
should be one called LED. These are actually specific names. So, you know how the sneaky way here is go ahead and use the search bar. The search bar, you quickly find it. So like if you do a capital LED, it should pop right up.
Mine just shows zillions of LEDs, but
No, in the search bar, so go into search.
Yeah.
And you put LED.
brings up a whole bunch of under LED.
Okay. Well, I'm not sure why, but pick one, just put it on there. Okay, I just want you to get some exercise actually adding it.
Now I see it. I didn't see it first time.
Okay. Okay, how many have gotten two? Oh, you having trouble?
Yeah, a little bit, but carry on. Then
Well,
go from there.
okay, are you in the symbol add symbol section?
I know I'm back a bit from that, so don't worry about me.
Okay, all right. Now, you use the add symbol, use the search box. You're going to the one that you're going to use an awful lot is CONN, which is going to bring up a gazillion of connectors. And you're going to know, you'll see that they all have a tendency to follow a certain pattern. There'll be a underscore, and then the number of rows, and then the number of the number of pins. That's a real common format. If it has underscore pin, we like the number 5 on this exercise, you'll see that it's not a socket, it's actual pins. So like DuPont pins, or like what we would call a male DuPont header, that would be one of those. Okay? So if you know LED, the R_US gives us the Ziggy line that we typically use in the United States as opposed to the rectangle that's used in the rest of the world. And the terminal, screw terminal, you know, okay, I had some of that. Okay. Here you can see sort of the type of parts we're talking about. Look at some down there. And oh, I wanted to add one to this.
Hey, Paul.
Can you put this in there, Paul?
No. So, it's a JST.
Yeah.
EH.
Yeah, that's XH.
Okay.
Yeah. And those, one of the things I highly recommend when you're making, you can use DuPont type style editors and pens, but they have a tendency to slip and fall off. So I on new robots, not wanting to make making my wiring more difficult, so I am using the same pitch, which is 2.54, which is the JST XH series parts, and you can populate them with the standard DuPont type headers or pin headers, or you can put the XH, and they have the advantage of being polarized and clickable, which makes your connections a lot better. Okay? And there's no more work. Okay. Let's see. All right. All right. Now, this one didn't get updated. So this is the files that I was telling you that are on the DPRG.org. Okay? Because what I want you to do next is if you've done 03, I want you to close your current project and open up the project that's in 03. Okay? That's a zip file, so you got to unzip it. And I would move it over to, probably move it over to your KiCad projects directory. Okay? Okay. So you guys, anybody, I know, tell me, give me a hint if you've got it. All right. Okay. You got it yet?
Yeah.
You got it? Okay. Close your current project. Take the 03 download, move it to your KiCad symbol, KiCad projects directory, open it up, and then I want you to click on the schematic. Okay, you should see something that looks like this. Okay, we're here. All right, now I want you to find the ERC icon, which is in the top. It's in the top of the schematic editor's window. If you find this icon that looks like this,
We can't see it up here.
no, you can't see it on here. You put on your machine,
Yeah.
you should see it.
Well, you said it looks like this, but we don't. We don't see any checkbox. We don't see the menu bar, the icons.
No, it's because the icon's not on here. It would be up here, and this is only the schematic. It's not full capture of the whole
Gotcha.
thing.
Thank you.
Okay. Now, when you click on that icon, you should see a couple of errors.
You go to do run DRC. It's that icon that looks like a bullet list with a check mark beside it.
Check mark, yes.
And then you go to run DRC
Right.
before it shows the errors.
Yes. Right. I should say you got to. Okay. Okay. Yeah. So it's find the icon and run
Yes.
to ERC. All right. When you do that, you should see 2 warnings and an error.
No, I get 4 warnings. No.
Okay. Well.
What do you got?
I get 4 warnings and an error.
Okay.
And an error?
Okay. So they must be.
Oh, it wasn't. Error wasn't clicked by default.
Okay.
A little checkbox.
Yeah. Okay. Down at the bottom, you have to click on the error box and have it show, or you can hit show all.
Yeah. So I now see 4 warnings in there, and that's
Okay. Okay. Well. All right.
I've got 9.
All right, I want you to try to spend it here. I'm going to give you 1 minute to find the error. Now, how are you going to do that? Well, if there's a couple things you should see here. If you look at the schematic, the error is going to have a little red arrow next to it. Okay, so if you scan all over the schematic, you might find that little red arrow, okay? Or you can, I think in the ERC, I think you can click the error, and I think it'll highlight the arrow, if I remember right. And I don't know why you have 2 extra ones. That's just, this was actually made in 808, and you guys had 809, so there might, I don't know.
I'm in 808.
You're in 808? Okay.
There's still only 1 error. It's just the 2 extra ones.
Okay. All right. Okay. All right. We're going to click on this. Okay, here's the solution, guys. I modified the connector that's up that's feeding the power into the thing, but I did not save it into symbol library. So it's a modified symbol. It doesn't cause any problems. This should be a warning. And it's not of a concern. And then the other one is there's an extra not connected symbol in the C4. Does anybody know what C4 means? If you look on the left side of the schematic sheet, you'll see it goes A, B, C, D. And if you go across the top, you'll see it goes 1, 2, 3, 4, 5, 6, sort of thing, I think. And if you go cross down into that, you'll find a little extra X in there. And it should have a yellow arrow next to it. Okay. Anybody find it? Click it away. Throw it away. We don't need that X anymore. Now, why is that? Why am I highlighting that? Is because when I go ahead and start clicking unconnected pins, I don't know, I have, mouse fatigue or something, but I always end up with an extra one somewhere where I just drag. I was flipping down and I leave an extra X somewhere on the schematic page. And this is an example of that type of error. Okay, it wasn't intended. Now, the error is there's a missing power flag on the B- trace. Okay. And so if you go, remember we talked about It should be the icon below place symbols. The next one that looks sort of like a ground symbol. Okay, if you click on that, and if it has a search box, you can just go PWR and it should find it. Or you can just slide down all of the different bus things until you find the power flag. There's one mark called power flag. Okay, you want to bring that onto the schematic and attach it to the B- trace that's way over on the upper left connector. You'll see one power flag for the battery plus, B plus. You want to put this on the B-.
So mine, when I click on that error, it shows a red arrow on the ground pin on J1 on the left. On pin 2, which is connected to a ground symbol.
Yeah, okay, but
That's the error that I see.
yeah, I think we're talking the same thing. Go get the power thing and put it in power flag on that trace.
Okay.
And you should see that go away. You might have to run ERC again. Okay, so we're going to talk about power flags next. Okay. All right, ready for the next step? Okay, power flags. They're using KiCad as a way to tell the ERC that power nets are connected to a power source where there's no explicit power source. So there's nothing there that tells it that it's a power source. So we have to tell it, we have to put a power flag there. The most common, and 99% for our robots, it'll be where the battery comes onto the board. So you have to have one on the plus side and one on the negative side. Because if you look at the connector that the battery is being connected into the board, you'll see that it says it's passive. All connectors are passive. So there's not, so you have a passive connected to a power input. So you have to tell it that it's a power source. Now, I guess you could, I've never tried this, but I think you could take a battery symbol, you put it over there, and you might not have to use the power flag. But you're not going to have it, most of the time, you're not going to have your battery actually on the PC board. So,
and then how do you deal with that when you go to do layout? It's going to be a component, right? You put a battery in the schematic. Maybe
okay. If you wanted on a PC board, you're probably not going to have a battery unless it's on a module, like for a real-time clock, or unless you're, you might have a keep alive battery. You know what I mean? If I lose power, keep it alive. And then that's a special case. There you probably, I'm not sure. That's got to be it. I haven't tried it, so I don't know. All right. Okay, so they're added. Those symbols are added on the power. It's found under that. Okay. Now, we're gonna do one more definition here. What is a net class? Okay, so what is a net? What is a trace? A net is a list of group components. So a good example would be VCC or ground. You got ground everywhere. Okay, that is a net. The ground is a net. But if I look at this B minus, it went from this one connector to the first power to the two power regulators. All right. So that is more of a trace. Okay. One instance of it. Is it a net? Yeah, I guess you could call it a net, but I don't treat them the same way. Okay. All right. Let's leave it there for right now. You can go back to this if it's confusing.
So my sense for a net, I've heard it defined as it's a bunch of pins that are all electrically connected.
That's
It's
good.
connections of pins, because
Yeah.
that's what you deal with when you
Not like
lay out.
VCC or ground.
Yeah, they're all
Or
going to pins.
SCL, or SCA, all of those, you may have it may be all over the place.
But they're all going to pins.
Yeah.
Wherever you are in the schematic, they're going to pins of components.
Yeah. So here comes the big rudder. We have a good example here of where the connector goes into the power regulators, which is connected to ground. So I have design rules for the ground net class, or the ground net. There's going to be right now, because we haven't changed anything, it's going to be the default design rules. Would I really want the battery power line to be the minimum trace of 0.01 something? No, probably not. But it's part of the ground plane. So how am I going to change that specific trace, if you want to say, to be thicker? Well, obviously I could go in later in the PCB, but I really rather have that denoted so that I know I took care of it and whatever. So that comes to this question here. It turns out that design rules can be changed for two ways here. Remember, we have a schematic editor and we have the PCB editor. In the PCB editor, you can change things like trace width, trace line, via size, those sort of things. In the schematic editor, we can change the representation of the traces with different sizes or different colors. So we could make, and we're gonna do that here in a few minutes. So let's take a look at it. The thing to know is in KiCad, each net is part of exactly one net class. Okay, otherwise the ground can be put in two net classes. That's going to bring a big problem up that we're going to try to solve later. Okay, but right now, so if you have VCC, all of VC is going to be in a net class. If we have design which are in that class, all of that's going to be applied everywhere. All right. Okay, so let's take a look. So let's look at this. Okay, we have this is trace width versus current for 1 ounce copper PCBs, which is the most common. Well, that's the common thickness of copper on all of the PCBs that we generally get made for $2.50 from JS. Okay, so I tried to put these guys in different places, and I turned out I ended up actually scooching them up to the lower. This is like me being first cut extremely pessimistic, but because we have some limitations too, because this is one of the places where the TB6612 module, it's got spacings between pins of 2.54 millimeters. So you have to be careful, or if we make it too wide, we're going to end up encroaching on other pins. So anyway, but here is this way I got it. So we're going to start setting up new classes. So we're in the schematic editor right now. So what do we have that we can change in the schematic editor? We can change the wire thickness, and we can change the bus thickness, but we're not using buses, and we can change the color. Okay. So now I want you to do, if you have, I want you to close this project down, and I want you to go to project 01. So that means take that zip file, put it in the KiCad project directory, KiCad project directory. Open it up, and it should say presentation file 01 or something, or 01 presentation file or something like that. Presentation project, I think. So you open it up as a new project. Okay, you got that? And by the way, if you got behind, this is a good time to start over again because we've got a new project in there and we're going to be working with it.
Yes.
Okay. All right. Okay. I'm going to do this because I know you guys, I know you're going to be really, 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 really attentive after you've eaten all your fill of pizza, and we've got a long way to slog through here. So what I'm going to do is we're going to cut it off, but we're going to say one thing here. What have we got done? All right. We're right in the, okay, after having made our library, putting our symbols in, and looking at a schematic with everything is put together, we talked about we talked about net classes, power flags,
DRC.
ERC. Now we're going to now we're setting up the new net classes, and that's a good place to put it for right now. Go eat pizza, come back here. You might have to get the extra caffeinated energy drink, but let's do it. All right, so what I'd like you to do, this is, you're still in project 3, I believe. Go ahead and open up so you go to edit, to file, slide down to schematic setup. Then you'll see this screen, but you might not be on net classes, so click on net classes. Okay.
We're supposed to have project 1 open, right?
Yeah. Last thing we left off with was project 1 open.
Yeah.
Should we switch over to project 3?
Well, let's stay in 1. We're going to do some stuff in 1. Okay. If you're in 1, that's fine. It's still fine. And go ahead and do what I said. Go on File, down to Schematic. This is on the Schematic Editor. Schematic Setup. Go down to the net classes, and on that you should see some already set up. All right. So I want you to go in here and create a net class. We're going to just, this is practice, guys. So just hit the plus arrow right here. Okay, and I want you to name it I²C. Okay. All right. And I want you to make it, I want you to, let's see what we have here. I don't want to change the line width per se, but well, double, yeah. Let's see, what is the normal one? Normal one is 1 something. What's the default? Can anybody
It's 6 mils is what it shows.
The default?
Default.
The default is 0.1524.
Okay, go to 0.3 then. I want you to, so change, so you created one, called it I²C. You're gonna go ahead and make the line width 0.3.
Millimeters, right? Is that
Yeah,
right?
that's default. You don't have to put the mm. And then go over to the color and click on it. And I want you to make it bright red. Okay?
And don't worry about the bus thickness because we're not going to see it.
Yeah, we're not gonna worry about the bus. Yeah. Okay, so now, while you got that on there, you notice we have nothing in it yet. Nothing's assigned to the S I squared C yet. So we're gonna, they changed something in around version 6. See this area right here?
Nope.
You're not showing your,
Oh, it isn't?
we're just seeing this,
The slide.
the slide.
Go back. Okay, you don't see this?
This is just showing the slide.
It's just showing the slide, not your active.
No, right here, you're seeing the slide, but you should see this section of the window that you've got open.
Oh, yeah, showing the net classes. Yeah,
Setting up
yeah.
net classes.
yeah.
I'm just saying, you just see this right here, this area down in the bottom part area.
Yeah, you're saying see this area here and we don't know where here is because we don't see your mouse.
Hey, you don't see my mouse.
No.
Why do you not see my mouse? Huh, I thought you saw that by default.
Unless, is my eyesight that bad?
Ooh.
You don't see
No,
it?
I use let's see. Well, I've been pointing at things all day. You guys have just been going along, okay?
We didn't know.
Okay, let's see. That's really a pain in the butt. Okay, somebody get on Google, PowerPoint, how to show cursor in slideshow. PowerPoint slideshow.
Oh. Yeah, maybe you have to take it out of slideshow mode.
Probably
Huh?
the equivalent of what there's like a laser pointer tool or something.
Yeah, there's a laser pointer
There's-
tool.
Right-click any part of a presented slide and choose pointer options from the menu. Next, click arrow options.
Wait a minute. Right here, Ed? Okay, now right click on
Any part of the presented slide and choose pointer options from the menu.
Yeah,
Next, click arrow options,
got it.
then choose the desired action for the pointer. If you always want to stay on, pick visible.
How do you see it?
No.
Okay, so that AI is not right. Let's
Interestingly, when I put my presentation in PowerPoint in presentation mode, I see my cursor without doing
Well,
it.
it's because it's mirroring the screen. I think that's why.
Okay. Yeah,
well,
screen mirror.
so wait a minute. So maybe I need to do that. See if this.
Yep.
Oh, yeah, there we go.
There we go. It's nice big and green.
Okay. All right, sorry guys. Now, this is the area that I was asking about. Around version 6, they made this less useful. All right, we'll talk about it a little bit later, but in the old days, what you had to do is if you wanted to assign something to a net class, you had to do it down here with the net class assignments. Now, you can still assign things to net class using that, but they made it funky, and because they were trying to drive people to use a visual technique to do it, and we'll talk about that. All right, let's see.
That's
So
okay as
what's,
long as they leave the other ways.
What's the wire thickness, bus thickness?
I'm sorry.
Wire thickness and bus thickness? What are the distinctions there?
Okay, if you open up the schematic view of project 01, if you open it up, if you look at the schematic, you'll see some of the traces are different colors.
Mhm.
That's what you're adjusting here.
I
So
can see
usually
that.
what I do personally is the more power the trace is going to go, the wider I make it in the setting. So
He's
like if
asking
you
about
look up at the battery one,
These are purely for the schematic then. They have
right,
nothing to do with,
they don't change trace.
thank you.
Okay, yeah,
That was the
'cause
disconnect.
we're gonna,
Okay,
that's next.
okay. Got it.
Okay, so now, if you go to your, okay, so everybody understands that now, right? So all we're doing is making the wires look pretty in the schematic. Okay, and now, I'm going to slide down one. Now I want you to go to the PCB editor and go down to board setup down here. And then I want you to hit the net class. And then you're going to see where you can change all the clearance, the track width, the via size, the via hole, and so on and so on and so on. Okay? So remember earlier we said if you think back, okay, we said that on the design rules for the PCB and the graphical properties for the schematic. Those are what you can adjust for the net class. Okay? Now, okay. Now, how do you put things in the net class? And I believe personally that when they made some changes, like I say, when they went from 6 to 7 and 7 to 8, and I don't think they really got it all correctly right yet, because but this is kind of where they're driving you to. The first way is to use the net class directive tool. And that's this tool on the right side menu. If you go over the right side menu, you can see one that looks like a popsicle. Now, I want you to go and find one of the global, I think I used global labels on all of the I2C buses, but I want you to go ahead and grab one of the global SDA lines and pull it over a little bit so that there's a wire. Okay, so you can see a little bit of wire.
Is this on the PCB screen?
Give me a second. I'll switch over to KiCad.
It'll be on the schematics screen.
Oh, thank you.
I don't think so. Okay. Okay. Okay, so we're in here, so I'm going to go ahead and look at the schematic with you guys. Okay, so I'm going to grab one of these. I'm going to use the pull-up option, so I'm going to grab one of these guys and just pull them down and see there's a wire there now. Because I had it attached right to the jumper.
Oh, so can you do that? Will they connect if you put two components with their pins directly on top of each other? Okay.
So now I'm going to go over here and grab one of these guys. This is the net class directive. Okay. And I'm going to, in the value, I'm going to put I squared C. Okay. And I'm going to want to point it sideward. So I'm going to click the sideward one. Okay. And I'm going to add. Okay, boom. Okay. Then I'm going to do the same thing for this guy. You gotta be consistent. Okay. Now, let's go back to the file page settings. And we click on that. Oh, excuse me. File schematic setup. And then go to that classes. And I'm going to make this guy bright red so we can see it. Okay. Okay. And if you look there, since I didn't change the width, but you see the line is red. The reason why they don't like red is because it's sometimes but you see now let's do this. We're gonna make a we're gonna make it 15.
Interesting, Gary Mills. Were in the building.
I think it moves. I can. You should not be using that. You should be using that.
Which type MM though, convert it.
Oh,
Convert it to
yeah, right.
those.
15 millimeter.
Quick way to switch between units is the
Oh,
Well, that's not quite what I wanted to do, guys. I didn't want 599. No, I gotta do that. I'm gonna go find the setting. Right now, this is, I don't know why, because I thought it was defaults into the millimeters, but here you can see the bright red lines, thick lines. So that's how you do it. Okay? All right. Now I'm going to do control Z out of that. And should be, check to make sure I got rid of it. There's no reason why you couldn't leave it there if you wanted to, but find it. So you go up here and turn it, yeah. The nice thing they've done in 7 and 8 is that these, both in the schematic and in the PCB editors, that classes are synchronized. It used to be it wasn't synchronized, and that got to be a little iffy. Okay? All right, now, we need to find out why. All right, I need somebody to do me a quick lookup. How to place KiCad in millimeters. That's really weird.
So there's that, it says there's those buttons on the left-hand side of the schematic capture that sort of inches or millimeters.
Right here. Okay, there it is. Okay, we're all good with the world now. Okay, it's not that I'm a real metric freak, but the more 3D printer work I do, the more CNC work I do, the more it's getting where I can almost understand what a millimeter is. So okay, we're good now. All right, so now here I'm going to so. If you roll your mouse, you can change the size of the of the schematic. And here's something that's very valuable, because it's not as obvious. If you push down on the middle mouse button with the scrolling wheel, you can pan. Okay, so that's a command that makes it nice. Okay, now let's see if we can get back to this guy. By the way, what's been up here on? Is any of this KiCad?
Yeah. We're seeing KiCad.
Okay, so we're back here. All right. Okay. Okay, so this is the second one. You can actually open up a label. So now go back to the schematic, find the FL_D, which is left front drop. So if you go into your schematic, it's over probably in the B, around the B area, B column somewhere. You'll see there's a whole bunch of, well, you can go look at the ESD and ESP, and you can look at pins 2, 3, 4, 5, and you'll see it. Okay, you see they've got labels?
Yep.
Okay, those are just wire labels. So I want you to get on top of it and click it. Okay. Then second, I want you to hit the add button.
How are you getting the dialogue? Click my net, how do you get the pop-up?
I clicked the name, the label.
Click on the name label.
Thank you.
Literally click on the label.
Okay, got it. Thank you.
Okay, and then you should see label properties.
Yep.
I see
Okay.
text properties. There it is. Okay, it came up.
Okay, then go down to the plus arrow, click it, and you'll notice that it drops in. The first one is a net class. And then you can use the drop down arrow and the value and set the net class of that line. Okay, so but just for grins, use motor power, and then go look at your schematic, and when you hit OK, and look at the schematic, and you'll see the color of that wire is now different.
And it shows the motor power text underneath the label.
Yeah. Okay. So now do a Control Z until the line is back to where it was. Okay. Very good. So you see, so that's the second way you can set a net class. Okay. Now this is the little section that I told you that on the 6 it used to be good, and now they kind of made it squirrely. And this is, you have to enter a pattern down. So we're on the schematic sheet. You go down to schematic setup, you hit net classes. So you see the windows, you see all the colors on the top. So go down at the bottom there, put slash, and I'm not sure I don't know what this syntax is. I'm not familiar with it, but it's some sort of standard syntax. But when you hit the /L, you'll see, and a star, you'll see the left-right drop sensors and the left-front drop sensors show up over here in the select. So you could, what was the one we did just finish changing the motor? What was it? Does anybody remember what it was?
LFD.
Yeah.
LFD?
Yeah.
So if you hit it again, you can change it from here. Now, just for grins, instead of /L star, I want you to put /right star. R star. Okay, and now you see the other two labels for the other two drop sensors, the right front and the left front. Okay.
Did you want us to assign them, or just
No, you don't have to. But I'm just saying is what I was trying to show you. This is a third way. This was used to be the primary way that you set stuff to the net classes. It's no longer the primary way. All right, now what is the advantage of this way as opposed to the advantage of the other way? Well, the net, if you do it here, the net list assignments will show up in this box. Otherwise, you don't really know what's assigned to battery because there's no listing in this net list assignment box. Used to, it would have been listed there. So you can look at that and you can tell where everybody was assigned. But now it's, you just have to, look at the schematic and kind of see how they did it. Okay? Now there's three ways you can set a net class. Now, the fourth way, but this is sort of weird. This is a custom. This doesn't really change the net class. Okay, so first of all, something has to be in a net class. Okay, this is all this code, little bit of code does is change the trace B minus to the rule, to a different rules. Okay, so because remember, B minus is part of the ground net class. All right. In fact, if you leave it as, so what you're doing here is you're taking one trace and changing its width requirements and spacing requirements. And this is how you can handle the fact that the battery input is part of ground, and you don't want all your ground lines to be set at 500 gazillion millimeters wide. You only want that one set that big. Okay? Now, Doug, what about, where'd you get this? Well, I tell you where I didn't get it. You don't get it from GChat or Chat GPT. You don't get it from that because I tried for an hour to try to Chat GPT, and I pay them money, and they still wouldn't tell me the answer. So I'm just saying is the best thing to do here is to go into. They do make it one nice thing. Down right here is a syntax checker. So whatever you write up here, you hit the syntax checker, and it reports. You see it's reporting no errors found. If you want to see an error, select the first line version 1 with the brackets. Select it and do a Control X or cut. Okay, and then hit the syntax checker, and you'll see it'll report no version, required version is missing or something like that. You see that? Did it give that error? Then put it back. So do a Control V. Okay. Okay. All right. Remember, guys, I don't expect you to retain all this. This is for you to know that I remember him talking about net classes or something. And then you go look in the presentation and what did I do? This is what you did. Okay? All right. Now, before you start the project, it's good to gather all the parts you're going to use. And why would that be useful? It's because you need to be able to make footprints or check footprints of everything that you got. That's why I handed out that little thing with the resistor and the capacitor and everything, because I wanted to go ahead and do that. Okay? Now, okay. So this is what's the final schematic sheet going to look like. All right, let's look at it a little bit. Okay. So we have battery coming into a regulator. These two regulators are tied together into plus that and ground. And they output, one of them outputs 3.3 and one of them outputs 5 volts. We have a little LED with limiting resistor here to tell you when you got power turned on. Okay. Now, so when the battery's plugged in, this light can go on. Wait a minute. Okay. What's this right here? Anybody tell me what that is?
Board power.
Okay.
Or the DPRG.
All right. So this is where this is a net class label. So this is where I've stuck the labels for the net classes. Okay. So I just stuck them over there. So I use net class labels for most of my doing. Okay. This particular robot project has 4 drop sensors. It has a dual motor controller. It has an ESP32 device kit version 1, which is a 30-pin version. It has a couple of pull-up jumpers that are selectable with a jumper. Okay, it has one servo connector for an SG90. It's got its SPL bus split out, which I guess you could use for a display or something. It's got what's the next one? A BNO85 breakout, I2C. It's got can't read this.
UART.
UART. Okay, so it pulls out UART too. It doesn't, and it also has a split jumper. You can either power the UART with 5 volts or 3.3. Okay, now the reason why that is because it's actually, it could be used with a TF Mini-S if you were in UART mode. Okay. Now, and the TF Mini-S uses a 5-volt power supply, but has 3.3 volt UART levels. So it's a little weird, a little unique, kind of cool. But anyway, it did make a little complication here.
So this sets the level of the serial interface. That jumper.
Right.
Sets
So like,
signal.
let's say you wanted to use it for a 3.3 part. You could set, which you would normally do, you would leave it on 3.3. But if you were doing it for a TF Mini-S in UART mode, you would move it over to 5. Because you don't want to change those levels to be 5-volt level on an SP.
No.
But that particular sensor uses a 5-volt power supply and has 3.3 level outputs. A little weird. Okay. Or you could, the next one I think is a TS Mini-S and I2C mode. And that's probably how we would use it. Okay, that would mean that UART would be available for other stuff, like the LiDAR. Okay, then the next one down is an ultrasonic ranger. That is a Seed Studio product that can run on 3.3 or 5 volts, so you can run it on 3.3. Let's see what else we found there. Oh, a start switch. And we have an extra I2C bus connection. And we have 4 jumper points. We have a couple of bypass capacitors. So anyway, and we have a little bumper switch over here. So now that's just, so that you can kind of guess what this robot is going to be.
Can I ask a dumb question? As not being a robot guy, even though I'm this group,
Yeah.
What is a drop sensor? You
Drop
mentioned that.
sensor is an IR sensor that looks downward.
Thank you.
So it says table,
Right.
infinity.
Tabletop robot
Could be.
Yeah.
Could be. What's it say there?
for the robot building class.
Robot. Okay. So anyway, this is a start on another project that Columbus had got. All right. So Okay, like I said, but you want to have all the parts ahead of time so you know what you're doing. Okay, now, this is one of the fun parts of KiCad. This is the footprint assignment tool. Okay, so this is where we're going to assign each of the parts that we have in the schematic to a specific footprint. This is where things can go wrong real quick, especially if you don't know, you don't have the part in hand and you don't have a micrometer and you don't know, like, well, is that, what? There's 5,000 capacitors I can choose from. Which one is it? Okay, so this is where we're going to do. Okay, now you could have these errors 2 and 3 pop up, especially if you're just starting KiCad. These probably will not show up. But if you've been using KiCad for a year, you're dragging a bunch of stuff from version to version. Some of it's been updated. And if you put your models, your project models, in the global library, you'll end up with crap like this. Okay, so that's why I always say put your models in your project library. Okay, now, so just hit yes and okay to get through that. All right, so we're going to show how you would select it. These things have got some interesting things. So over on here are all the available footprints. Okay. Here you have a little search box or filter box, I think they call it. And these are 3 different filters. If you click on this first filter or just hover over this first filter, what does it say?
Filter footprint list by footprint filters defined in the center.
Okay. What's the second one say?
Filtered by Pinkin.
And what's the third one say?
Filtered by library.
Okay. Now, you push on those and they go like the 2 on the right, or if they're not selected, they look like the one on the left. Okay. Now, look down here. Oh, what happened? You look down here, you can see how this was filtered. This list over here, here's the filter results over here. It was filtered by pin count 2, library LED through hole. What's this? It's a 72 screw. I used to know. And there were 72 matches. Okay.
So I don't
Okay. So,
I don't see the same thing on. Do you guys see the same thing on the bottom when you click those right to?
well, you have to click on a part. So click on LED.
Oh, thank you.
Are we in the schematic editor or the PCB editor at the moment?
No,
This is in the this is
Oh.
schematic editor.
Schematic editor.
Okay. Okay, let me go back one. Here's what it looks like.
It's on the upper right of the icons.
Up on the top,
1, 2, 3,
it's
4.
called
Fifth
assign.
fifth one from the right.
Yeah, it's like what we should say.
Just to the
Got it,
left of the
got it.
computer.
Thank you.
Okay.
Yep, thank you.
Okay.
And now I see that with the LED clicked, I see what you were showing.
Okay. Okay. And because this is a 3 millimeter through hole one, I clicked on that. Okay. So I've assigned to the LED that's on the board to that one. Okay.
Out of curiosity, when you look at which shows the footprint you've selected, what does the number mean in front of that, like at 2206? In that right column? Oh, I see something. Mine looks different.
Yeah, because you've got it because yours is fully populated. Because you're in project 1. I should have just told you to go to project 3 and you could do this and it wouldn't be populated.
Okay.
But I've already assigned all of the footprints. Okay. But you don't, if you were in project 3, it would look like this, because none of the assignments have been made in project 3. And so if you want to do that, that's fine, but we're going to use project 1 probably. You're just going to have to pretend that it's version and it hasn't been completed.
I just want to make sure I wasn't
Yeah.
messing something up.
All right, now, we're lucky because our parts, mostly standard parts, like connectors, resistors, LEDs, and capacitors. Okay, the modules we are using, they will require finding or building footprint. But I will tell you that the internet is your friend. You can almost find a footprint for everything. Now, is the footprint good? It's sort of like if you're a 3D printer and you go out to Instructables, there's a lot of files out there. And when you find a good one, it's really golden. But for every good one you find, there's some real dogs. And same thing when you go to the internet and you'll find somebody, oh yeah, I ran into that the other day and I made one of these. I've made one. And you go look at it and say, you made it, but if he used it, he had a lot of errors. You know what I mean? So you have to be careful. You have to look. And since all, at least right now, all of the standard modules coming from China use 2.54 headers, or what I'm calling DuPont header. They just call connector header pins. And those, because they're all standard, and they're all very old, there's lots of things. So if you have a module that has a list of pins on one side and a list of pins on the other side, and they're 2.54, you can just use connectors. You can create your own footprint by starting with one of the headers and then duplicating it and sliding the second copy over the right distance, and you're good to go. You have to make some boundaries and a few other things, but it's a big head start. So, okay. So here's an assignment exercise, but it's already done. And if you really want to do this, go to the project 3 and fill them in. If you don't want to do them, take a look at the assignments that have been made already in the one you're looking at, and try to get a feel for what's there. Okay, kind of get a feel for how they name it. Now, so they typically they'll have something. Let's see. Okay, here's the answer. So here's something really. So this is the diameter of the body. This is, oh no, excuse me. This is the end to end. This is the width, and this is the pitch of the leads. Okay, so like if you have a resistor, for people that are not here or can't see this, I'm sorry, but that's what it is. Resistor.
Yeah, that's a little.
So from here to here is the pitch. Here to here is the width. And from the end of the body to the end of the body is the diameter, or the D. Okay.
Well, this says L is 6.3 and D is 2.5. Is that
D is this distance.
good?
This distance is this distance. It's really not quite. This one's smaller than that, but it's good. You have to know when to cut your losses. And the spacing between the pins is 5 millimeters.
Right, but so you have L at 6.3 and D at 2.5. Can you show me which one is, shouldn't L be the body length and D be the thickness of it?
Yes, you're right.
Okay.
Okay, I was looking at the capacitor. I'm sorry. Yes, you're right. The L is this one. Okay, thank you. Okay.
So in our, since we have a populated one, I guess the number in that is just the, which number in the list of capacitors it is, 1, 2, 3, 4, 5.
Yeah, like if you're using, in this case, the bypass capacitors are all the same. I think that's 1 through 4, I believe. So you just go.
Right. I'm just asking, in the list that we see with it populated, it's got, all the way, I'm looking at 400, 400, 404, 405, and the one for C1 is 427. That just happens to be number 427 in the capacitor list. Is that what?
I guess. I'm not sure.
Okay,
I
we
don't
can't
have
say that.
access to it right now. But, yeah. Okay. Okay. Now here's the footprint editors. Now, if you actually have to make a footprint, okay, these are the tools, the drawing tools that you use over here. Okay. The top one is add pin, and probably is the most important one. Okay. But what you can do is you can start off with one that's close to what you want. You can find something like a connector, and then you can bring it into here, modify it, and save it under a different name. Okay? But if you do that, make sure that you put it in your project library. All right, for example, you see where it says libraries filter? I want you to put in the word presentation. And our project library should show up.
Yes.
Should pop up real quick. So if you use the drop down, you can see all the footprints that we have in that library. Okay, I'm not actually going to draw one because I hate drawing in this stuff. And it would be about 6 foils, and we would get through it, and we would go, I don't like doing that. So we're just going to, like I say, we're just going to scrounge the internet until we find what we need. And okay, so but okay, so here's, how we create a symbol library, symbol project library, where we put all our symbols in. This is how you do the same thing for footprints. And it's the same procedure, except you start off with the footprint editor as opposed to the schematic symbol editor with the symbol editor. So you get the football editor, and here's the icon. It looks like this. Okay. You go second, you create a new library, new library. You select project, hit OK. Then you take it over to the presentation, where the presentation file lives. That's where I like to keep my symbol and footprint libraries. And you put in presentation project line, and when you get finished, you should be able to put present in the filter, and it should show up. Okay, when I did this, it was empty because the drop down shows it. But if you do it now, drop down now, you should see some footprints. You want to make sure it's created. It is created in yours, so you don't have to go and create a new one. You may be able to just do write present in filter, library filter, and it should pop up. You shouldn't have to do this because it already existed. But if you were doing it new, this is how you would do it. Okay. Everybody with me? All right, we're going to get one more slide here. So now this is adding your footprint to your library. So you've made your footprint, you made your library, but now you want to put your footprint in your library. And this is how you would do it. You're in the footprint editor. You go down to import footprint. Then that'll open up should open automatically your footprint directory. Then you select it, and then you okay. There's an okay or a yes or something behind on this screen, and then when you do that, it should be in there. Oh wait a minute, no, you just in it. So now you have to go to you need to select the library, and yeah, here it is. And when you save it, and you got to remember that you got to save it. There's no auto saving here. You got to save it. If you don't save it, it's gone. So now, the thing I want you to know, since you already should have this on your project now. Okay. There were two modules we didn't have. I didn't have one for the ESP, two footprints we didn't have. We didn't have a footprint for the ESP32 development kit, and I didn't have one for the TV6612. Well, this is where I found them on the internet. Now, the second one is snapeda.com, and they have a lot of footprints. You'll find them, they have lots of stuff that you can use. Now,
and good quality, right? The quality footprints decent or
better quality.
better.
Better quality. Sometimes their symbols are funky, but usually the footprints are good. Okay, now, so this other one, I just found that one where a guy claimed he had one for the ESP32 module, and I dropped it down in there, and I found that his pins were numbered 1, 2, 3, 4, 5, 15 on both sides. You know what that did? Not good.
Show them together.
So I would go back into here, into this set, bring it into here, and I just renumbered the pins. Very simple to do. Okay, so it's something you need to. So never just take it at face value that what they got on the internet is good.
Never assume, right?
Yeah, never assume on that. Okay. Now he did a lot of the hard work for you, so I mean, I can't complain. I'm just saying that I really wanted to see him. I wanted to see him. He was really proud that he had it up there, and because he was answering somebody's question on the internet. And I just happened to be working on that lately. But he obviously had not tested it. Okay, now, so here's what it looks like with all the things done, and this you should see. This is what you should see when you open yours up. You've already opened it up, so because when we were looking at the diode, you see it all. It's all here. Okay. This is project 1, so you should see it all. Okay. All right. The actual editor page. Whoa!
Moment we've all been waiting
Yeah,
for.
what you all been waiting for. Okay, now this is the magic button we want to push. All right, when you're ready, when you got all the footprints assigned. Okay. Now, there's one thing you're going to notice here when we do this, and then we'll talk about it next time. Okay, so let me make sure. Everybody close their eyes. Okay, we're going to talk in a sense. Okay, never mind. So anyway, but that's the magic button we want to push. All right, so let's first talk about the editor tools. Okay, on the right side, on the far right, there is the appearance where they have all the labels. The key ones the ones that you're going to be using all the time are the copper levels, and you might have 4. If you had 4, there would be F dot copper, IN1 dot copper, IN dot 2 copper, and B copper. But we're only doing 2 levels, so we only have front F dot copper and B dot copper. Likewise, you only have two silk screens, the front side and the back side. And then you also have the edge cuts. The edge cut is the shape of your board, basically. Okay, that's where you set your board shape. Okay. Now, a little far to the left, and ask Doug why he did it this way, backwards. But anyway, these are the icons you're going to be using. So the first one is select, which is always important. Local net rest shows the rat's nest in a certain area. And you say, well, what's the rat nest? Well, you're going to see the rat's nest in a minute. Okay, add footprint, that's important. Route tracks, that's important. Tune length of single track, add vias, important. Add field zone, important. Add rules zone area. Now that's actually pretty important. Could be used, especially on this one, because we're using an ESP32, which can't have a ground plane underneath it. So we solved the problems by hanging the antenna over the edge of the board. But you could use a rule area to create an empty area underneath it too. So that's a possibility. The next group are drawing tools, which can be used to form the edge of your board. The next one is add text and text box, but these will not show up on your PC. Okay. Maybe. I can't remember. They might show up on your PC. I can't imagine having a text box. But anyway, text might be how you add like your name and stuff. I have to check on it.
Yeah, that'd be on the silk screen, right?
Yeah, you put it on the silk screen.
Not the text.
Yeah, so, okay, you can add dimensions, obviously that you don't want on your board. There's a deletion tool, which hopefully you never have to use. Then there's interactively measured. That's very good for like measuring distances. That's actually a nice tool. Okay? So now we've kind of gone over the PCB editor tools. You also got stuff on the top. There's the footprint editor. So you know we've already looked at the footprint editor. There's footprint libraries. That's where you can add an external library or view the internal libraries. You can look at them. There's a 3D viewer. Okay, a 3D viewer is standard. A lot of the symbols have an actual step file 3D view of the part. And so when you create your board, you can actually make a 3D rendering type of the board when you see it. It sounds great, and I can see where it'd be useful, but the problem is, like, we created some of our own footprint. We probably not going to go through the problem of creating a 3D cart for it. So it's of mixed use. Okay. The design rule checker, we all know and love and hate. You can switch back to the schematic editor. There's a scripting console. I'm never wanted to program in KiCad myself, but some people do. And then our add-ins. Okay, let's look at what we've done. We completed the schematic by making the design, adding and making the symbols, and completing the wiring. We've assigned net classes and passed ERC. We've assigned footprints to all the schematic parts. Okay, the parts that are remaining are placing the footprints and rat's nest on the PCB, and then arranging the footprints in a logical order. Routing the wiring. We will use a router, Autorouting, which is going to make this so much better. You're going to be so much happier. Okay, and we're going to print a copy of the final PCB, and well, we're not going to do that, but this is what a technique that I highly recommend for us amateurs. You can print out a copy of PCB with a scaling of 1:1. And then you can take all your little parts, place them on the paper, and make sure that they all fit. That's a really good way to get started. Okay?
So,
Huh?
you know, you mentioned that for what we're doing here with the 3D models are not so great, but it is kind of neat if you have the models
Oh,
in 3D print your board with the models on.
Yeah, I mean,
That's kind of cool.
the problem, like I say, is I've never made a board where all the parts had the 3D model. So, you know, it looks a little weird when some are populated and some aren't populated. But I'm not having anything against it. I'm just saying.
No, that's more just kind of a fun thing.
Yeah,
It's
yeah.
not essential to me.
Okay. Okay. And then, so after you pass the paper print test, we're going to send the PVC design to the PCB manufacturer. That's what we're going to do. All right. Push the magic button. Go ahead, guys. Do it. Push it. Go for it. All right. And it should look like this. Well, yours isn't going to look like
Yeah, ours is done already.
that. Yours is done already. So hey. Okay. I want you to do this. I want you to create a new directory, call it presentation version 2. Bring everything that you have in version 1 into version 2, and we're going to screw it up. Okay?
I'm right.
Okay? Everybody willing to do that? All right. So just copy that whole directory over into, you should, if you just copy the directory, it should say version, presentation version 1/copy if it's a Windows machine, and then just rename it to presentation project 2. Now you're going to use that button. When you get there, you're going to use the button that I said, hopefully never have to use. Okay, everybody got presentation 2? When you have presentation 2, pull up the open up presentation 2 in the the other thing you might have to do is name the you got your presentation 1 in a safe directory, so you're okay.
Yeah.
All right, so you go open up presentation 2, but it's going to say presentation 1. Okay. And then go to the PCB editor and do a select all. and then hit the deletion tool.
That, and so the board outlined everything.
Yeah, everything should be gone.
All right.
Okay, everything.
Dead Jim.
Yeah, so now,
Try to match your button.
now push the button. Remember what the button is? It's that one.
Yeah.
And now you should have something that looks like this if everything went right.
I got a pop-up that said, changes to be applied, replace footprints with those specified in the schematic. So,
Yeah, just say okay, wherever. Yeah, you want to. Did you get this yet?
yep.
You got that? All right. Now, I want you to select, go ahead and try to select, let's be dramatic. Select the ESP32 module.
By the way, your ESP32 shows all the lines going straight
That's
down.
because I had to fix the
Yeah,
the
okay,
number.
just make sure.
That's how I knew I was screwed. Okay. Yeah. Yours shouldn't show that.
No, it's just got everything crossed.
All right, okay, yeah. All right, now pull it away from this. Just pull it away. And you should see the rat's nest.
Mhm.
Okay, that's a representation of every wire there, okay? Okay, so every trace here is done sort of like with a little magic rubber line. Okay? All right, so now okay. Here's where PCB designers earn their keep. You know, is they know how to place their modules on the PC board to minimize area, minimize noise, minimize crosstalk, all sorts of minimizes. Okay, we're amateurs, so we're going to run like some things that we think. Well, there should be a drop sensor in every corner. Sounds good. The antenna of the ESP32 needs to hang over the edge of the board because we don't want to make an area of it. The distance sensors should be near the front of the board. The motor driver should be on the edge because we're going to go to terminal blocks. And the same with the battery, it's got to be on the edge because it's going to a terminal block. And it's probably going to be on the back of the robot. Okay. All right. So this is how, when I did that, this is how I solved the problem. Okay. Here's how I arranged them. It is not the way, it is a way. Okay. This is, again, you might be able to squish them up closer together. You might be able to, because I gotta be quite honest, some of them may say how big this board was. I was hoping if I could get it by 100 by 50. And that would be a real challenge because that way we could get two boards for one of our 5 boards. Whoa, that'd be cool. So, I mean, but right now, that's not what's going on here. So this is how I arranged it. And the one you actually have in presentation 1 may be different from this a little bit, okay? Because, I'm back. This is where your OCD is going to kick in, dude. Okay? All right. Okay. All right. Now, I want you to go back to project 1 again. Well, no, hell, keep this one where it is right now. It's absolutely the minimum. Bring your module back. Do a Control Z. So they're all close together, right? They all look like this. Okay? All right? Okay. Now, this has no logic, so let's not pretend that this is the way we got to do it. But what we're going to do is I want you to go to the pre-routing button. Oh, and now here we may run into a thing. You have to have Java installed. So if you don't have Java, it's going to complain. Go ahead and just put Java in, install it. Okay? This is worth it, dudes. And so I'll give anybody here that needs to have Java installed. Well, okay, hit the button. It'll quickly tell you don't have Java.
Are we autorouting?
Yeah, it's a Java application. So if you don't have Java, it might be included if you want to install it or update it. I don't know. Try it.
The slide says we need to add a border.
Oh, yep. Down right here, you need to add a border. Okay, so what I want you to do, since we're just playing around here, go take the rectangle tool and make a box around all your parts.
We have to select a layer.
Yeah, you have to select edge cuts. And just make a box around it. So you guys got a box around it?
When I draw the box and let it go, it
Yeah, it's a click start.
Yeah.
yeah, it's a what?
It's a click start and a click
Oh,
start.
click start. Thank you. I was doing this.
I was trying to drag it too.
Yeah.
Thank you.
Okay, so now you got a border around an edge cut around your thing, and this is pretty typical, basic edge PC board.
That's
Not
really
very-
cool.
Not very. All right.
Plug it in traces for all it's worth.
Okay, so is it chunking?
Yeah.
Okay.
That's really cool.
Yeah, I don't have a job. So.
Yeah.
Wow.
Did it
Did
successfully
it
Yeah,
routed
it did.
everything?
It did. Wow. That's amazing.
Okay, now we're going to go through the 47 slides on how you can do that manually.
Hey, this whole 4 hours was worth it right here. Free router.
All right, so you saw, I don't know how long it took, what, 5 seconds, 10 seconds? It's pretty amazing. And,
Yeah.
Okay, so anyway, I wanted you to see that to become a believer in it. Now, okay, while you have free routing open, I want you, let me see if I can do this. Give me a second here. Shift tab. Escape. And
That's amazing.
all right. Yeah. All right. Now this one, I don't know. I wanted to open up, but I don't know. I want you to look on. Okay, go shift back to your original presentation one. Okay, so close this presentation out. Go back to your original presentation one and open it up and open up the PCB. There's one setting in free routing that I like to set, and I definitely think another area for your OCD is to play with the free routing settings, auto routing settings. There's some things that you can push or create that are pretty cool. So, but let's see if I can open it up. I'll try it, but last time I tried this, it didn't update.
So I was a little concerned about updating the Java, but it puts a local copy and it looks like KiCad project.
See, mine's not, I don't see it. It's not popping up. Well, maybe it could be my old computer is so old that it, yeah.
There it goes.
Okay, now I'm gonna hit the, I didn't want it to start, okay?
And if you get that start screen, hit cancel.
Yeah.
Stay up.
Okay, let me try it again. I'm sorry, guys. And we'll see if I can get it. Should be faster though. Because now it's supposedly it's updated.
What's cancel? No, to the right. There you go.
Cancel. Okay. All right. Okay. In the general settings, it's not too interesting. But I'll close that. Settings. I think it's the routing setting.
Routing or auto routing?
These are some that you can play with. The other settings, I think it's the auto router setting. All right, so here you have a couple of things you can do. If you're at home and you're doing toner transfer, and you really want everything, you want to minimize the vias, and you want everything to be on one level if you can help it. So here you could turn off the backside copper. Okay. You can also play with the via costs and the rip-up cost. You can use optimization, as I understand it, and this, I might be wrong here, guys, but I think optimization is that after it routes it, it tries to minimize trace lengths. And it can usually get about 20% smaller, less trace lengths. So you might want to hook up on fan out. When I played with that, I didn't really particularly like it. Okay. But there's one setting and I still haven't found it. Gotta be that. Oh, all right. I don't like to restrict the pin exit directions. Okay, so if you look over here at this guy, do you notice that everything, when it comes in, there's none of this where I have a connector and it comes in down. So I have two pins and it comes down and goes in between the two pins and connects. I like to uncheck the restrict pin exit direction. Now, play around with it, do it yourself, see what you like.
But what does it do? What does it eliminate or
It
enable?
requires I think it has to do where it can only come into the pin in certain points. Okay.
Okay.
And like I say, some of those in the past, I always saying, I don't like the way that is. So I would go in and edit those out. And then I realized, oh, I could just push this, unclick this, and I didn't do it. So I'm just saying that's something to consider. All right.
On the auto routing for the single layer, I was hoping to see a setting I don't see, and that is it doesn't have an option to automatically add jumpers. If you really wanted to, sometimes you can't route something on one layer without having little wire jumpers. And
yeah, well, I'm trying to think.
I don't see that on the
I think it does it.
Oh, it does it. It just
But I'm just trying to figure out.
has it because it has to
I
know
can't
what.
even, I haven't made a toner transfer PCB in many years. And so I know that you wanted to minimize the jumper.
Right.
You wanted to minimize, since you're only on the top, I think it just puts a V on two sides of the line.
But I mean, it has kind of no settings for how far the vias are or what size they are. Or you would think you'd have to.
I think they probably inherit that from the design. You see, it does have, you have net classes. So, it has the rules here. And it has, let's see, here's all the nets. If you wondered what the nets were. Okay, these unconnected is where I have one of those little X's. Okay, so those are all the lines, which, by the way, this is a good cheat for when you're in there trying to make way 3 of signing net classes. So that's something to think about. Let's see what else is in there. Now, here's the VIA ones. VIA rules. I'm not going to push any of these buttons. You can go ahead. You can practice. You know what I mean? When we're almost finished, and I really don't want it to go to hell in a handbasket. Okay. So now, okay. All right. So I'm pulling out of this. Maybe grab the do not save. Fix problem. Try again. I don't know. Oh, it's really okay. I think what it just told me was it didn't, since we didn't do the routing, it didn't create. So how, if you look in your files, you'll see there's a free routing.ses and there's a free routing. There's another one. The one of Spectre file, which is what it sends it out, sends one, and then it returns the other, and then you import the other one into your thing to get the wiring to pick up. So what they're telling me, well, all my wiring's gone. See that one? I should have done it, Doug. You should have known. You shouldn't have done it. All right. Anyway, let's see what happens when I do Control Z. Can I get that out of it? That's bad, guys.
I think you lost video. The screen is now saying no cable connected. Maybe the cable came a bit unplugged.
Yeah, it's out. It's gone.
That's that. Further across.
That's further across. There you go.
Huh.
There it is. Now it's back. Yeah.
Okay. Yeah, well, I lost all my wires, dude. Well, I know. I don't know what I mean.
Import update from Schematic.
Yeah, I might have to. See
You
what
haven't
happens.
saved it.
Let's see what happens.
It's going to save it. I mean, it's not saved.
Right.
You
Yeah. You can
Oh, yeah.
reload
Close
it.
it.
discard it and
Yeah.
change it.
Yeah.
What?
Reload it.
Yeah. You just reloaded. Yeah. You didn't.
Okay, I'm not sure what you said. Okay, reload one.
Yeah. Kill it.
Close this and stop
Yeah.
it,
close
and
it.
don't save it.
Yeah.
This is going to change.
Change.
Yeah.
There you go. Now reload it.
Okay. All right. Thank you, guys. Ah! They're all back. Okay. Now, let's go back to the presentation. Okay. All right. So we had, let's see.
We did that.
Did we jump around? Yeah, we did that. We did that. And we said here that you had to make sure that you had, I probably ought to put that in red writing.
I mean, will it try to route it? Just size
You
of
need
the
to add
sheet?
the edge border before you run them through routing. That's just I don't know if this stage or not. One of these days, I'm going to have a good rant talk with our Microsoft expert because one of the updates, all of a sudden, I'm out on OneDrive. I mean, everything, I don't know where it is. Anyway, so let's see, we'll go from this current slide. And we didn't want this. Duplicate slideshow. Okay. All right. Okay, here's some board boundaries. Now, show a couple more words here. I don't know what's going on, guys. This right here is a fantastic little how to make custom shapes. Make like badge, you know, like people who have show badges and stuff. And I made both of these PCBs using a round one and rounded edge with big holes in the corner. Both of these use those techniques. I tried to do it in 8 and something not working right. And I don't know. I didn't have time to find where my problem was. So it's probably me. But anyway, here's a couple of special. These are all from GALC PCB. And they represent different levels of me learning how to do it. And anyway, these are a couple of worthwhile things to take a look at. You know, here's my thing. It's really not good at detailed graphics because, you know, it would be so much better if they would say, okay, I make a box like in other programs, and then I could set the size of the box manually by typing in values. They may have added that in 9, I don't know, but in the past, and I don't even know if it's in 8, but in the past it wasn't, okay? But anyway, this is some things that you ought to take a look at. All right, so we're going to talk about fill zones now. In fill zones, if you look at the rectangular one, you'll notice that it's got a lot of fill zones on it. The circular one doesn't, but the round one does. And here's an example by, if you make your smaller ones, you can panel. This is also from them, and it's a panel board.
Now, did you panelize it in KiCad or did they panelize it? I'm trying to ask a question.
Whatever way I did it, it was easy. Okay, I remember that part.
All right.
The JLC upload does that part.
But I think you can. I think they'll panelize it
Right.
for you.
I know there's
Each way
tools
one image.
for KiCad that will do that.
Yeah.
How does that work?
Huh?
How do you set that apart?
Your virtue bar?
Yeah,
They
you
cut it
see
apart.
they have a little V carve
How
down.
would you cut it apart?
Yeah.
Snap manually.
They snap really easy.
Oh, yeah.
It's tempting. Don't
Yeah.
break that one.
Yeah. Yeah, don't try this. Try it at home, not on duck bowl.
Okay, but I'm just saying that that's kind of cool. And okay, so one of the recommendations with free zones that zone fields that they recommend is that you go into File, Board Setup. You know where that is. You've done that one, all right. In the PCB Editor, and select. So in this case, let's see. Under constraints, so you're using this guy right here, constraints. Change the copper to edge clearance from 0.5 to 1 millimeter.
It's already done in ours because it's the finished.
Yeah. Yeah, it's already done. I mean, it's okay. But just remember that if you got a new project, you'll have to do that. Okay. Now,
Just to keep your copper from getting clipped when they saw the board, right?
I think so.
Yeah.
Yeah, if you want some distance between the cut and the edge of the copper. And So if you pick the fill tool, zone tool, right here, okay, and we want to draw a zone around the whole. So I believe when that happens, you're going to get an icon that has it's a crosshairs with looks like a drawing tool. Okay, so if you touch the board, you probably see this pop up. You might have to drag it a little bit. I got to admit, this is a little unclear how to get this thing. Sometimes it pops up easier than other times. You guys get it?
But ours is already filled, so.
Oh, okay. That's the point. Okay. Select the edge fields. Now you probably is this your good copy of one?
Yes.
Okay. Well, you can always download this again. So go ahead and select the edge, the fill zone boundaries, and then use the delete tool, or just hit delete, I think.
Yeah, that deleted one of the folders. I think it's got two of them, one on each
Oh,
side.
which one did you delete? The ugly one or the neat one?
The first one.
Okay, well, delete them both. What the heck?
Oh, okay, the red one, so the top side, and then that showed the bottom side. So delete both of them, top and
You
bottom.
can. We can do, probably a good thing to exercise.
Yeah, delete. Okay, so they're both gone.
Okay, all right, now hit the selection, the zone fields. Yeah.
Okay. And do you have to then go select a net or just,
Okay, well, when this pops up,
yep,
then you need to select the net. So we'll do front side,
okay,
and then we'll select, then you got to select the net, and we're going to select ground.
okay.
Okay? And then we're going to hit okay. And I believe now you have to draw the zone. Were you able to draw the zone before this popped up, or?
No, it's going to draw it now, but it picked the starting point where I first clicked.
Yeah.
Yeah,
Well, you get ugly ones.
it gives you a clicker, a pointer that you can click around and fill it.
Control Z if you want to start over.
Now, it's close enough to the corner of the board. It's gonna be
Okay. Okay, you got it?
almost.
Okay.
Is there, do you know if there's a key on here when you're, say, dragging your line down, if you hit it, like that will keep it, keep it vertical or keep it horizontal?
I don't know, but I would suspect control, but I'm not sure.
Yeah, it lets me move it anyway.
Okay. So you should have some like shaded slash areas all the way around the board. Okay? All right. Now, okay, we all there? See, are you ready, Paul? Okay. Hit B.
Very nice.
Can you fill it in? Oh, you look so concerned. I don't know if you've got it or not.
Or just concentrating with it.
Yeah.
Now, if you want to,
Yeah, fill it in.
okay, if you want to unfill it, you use Control V, and that will unfill it. Now, you say, well, why, Doug, would I want to do that? Well, you might want to do that because you found you needed to make an adjustment to the board. Because the fill area will, every time you hit V, it recalculates and adjusts for whatever you've done.
Well, it is nice because it lets you, when you unfill it, you can move the corners, you can move the.
Oh, you can?
Yeah, you can move the edges.
Okay. I gotta admit, I'm sure there's some subtleties to this, guys, that I just haven't run into it. Okay. Now, everybody,
Or unfilled.
fill them back up. You can do it on the back side too, if you want to. So you just change, you just create another zone, change the backside copper. Then I would use 3.3 volts probably. And, and you should have now on both sides. Okay. And so this is, yeah. Okay, so this
Okay,
is
say
what I just told you.
you have isolated areas. Will it add a trace to bridge between like an area that could be filled if it had an extra trace or something?
You won't have floating islands.
Oh, it will not?
You won't have floating islands.
That's nice.
Okay.
Very nice.
Yeah. So it will add a trace then. Or it just won't make a floating island.
Yeah, we just won't make it fill at all in that area.
Yeah, it won't make
Okay.
it float in that
We
area.
can't connect it to
Yeah.
the net if you plug it in.
Okay. Thank you.
So this is an out of band question. So is there a way to easily see the back, flip the board around so you can see the backside view?
Yeah, go to, okay, do you have them both bead?
Yes.
Okay, go to the copper layers and click the show arrow. It looks like an eyeball.
Okay, I see that.
You can click on it,
For which layer?
which one you don't want to see.
No, I just want to flip the board around. So
You want to see it back on that.
backside, yes.
Uh,
Like if I was placing backside
okay,
components.
we're going to be able to do that in the Gerber viewer, but I'm not sure you can do it here.
Okay.
I wouldn't be, if you had the 3D view, you probably could. So that's an interesting, go to the 3D view button and see what you see. See,
And I was looking at it's got a mirror horizontally. I don't know, that just mirrors what I just did. 3D.
remember, you can always back out with a Control Z.
Yeah, that like build it like you show and left the other nets and ground all like isolated, running their own traces. That's pretty cool.
Okay, now sometimes you'll see, you'll do an adjustment and the fills will recalculate and they'll show up. They have to do Control V to hide them again.
Yeah, DRC redoes the fill. When you click the DRC
Yeah,
button,
probably.
it redoes the fill.
Yeah. Now,
So you can hide the fill actually without undoing the fill.
yeah,
There's
there's
a button on the left-hand side where there's a shadowed arrow.
Oh, right.
You can click that.
Oh,
it
yeah.
hides it.
Yeah.
Can you add mechanical mounting holes?
but this is usually the last step that I do.
Ray had
The
a
last
question.
step here, before we go create the Gerber files. We're going to create the Gerber files and we're going to package them up. And then we're going to go to the JCL site.
Ray had a question. How do you add mounting holes
You mean inside of the border,
inside the
Yeah.
borders?
Well, okay, Ray,
Yes. Don't
that's
do that.
why I said I like to use Inkscape, but I can't use that now. But you can use the circle tool. You see there's a little circle tool. You can do that to drop holes into the border, into
Okay.
the border,
What layer would you select?
edge cuts.
Oh,
As a side note, there's another way to do it, and that is they typically have components for a mounting hole, and you can actually add it to your schematic and actually just place it
Yeah, that's
like
true.
you do
Yeah,
like you do any other component.
that's exactly right. I forgot about it. So Ray, what he just said was there, if you go into the footprints, there's, what is it called?
I don't remember offhand. It's
Yeah,
different.
but it's
different
basically a
models.
big hole and you can put it in. I don't remember the name. I've used it, but
I think if you go to your schematic and you add a part, add a new symbol. You can search, I think if you search for M&T
You'll find it.
mounting hole, you'll find some.
Yeah.
And they usually have them for standard screw sizes and whatnot.
Yeah.
And they can have them either as grounded or ungrounded,
Right.
so you can connect them to the ground.
That's probably even better, because you probably have to, if you wanted one that was perfectly safe, you probably would have to create a masking zone around it.
Yeah, and you want it in your schematic, even mounting holes, this traditional practice.
Oh, no,
Yeah.
I do too.
Yeah,
Well, that's like I say, this is much better. You know, these guys, they're depending on the standoffs that you use in the corner.
Under
No.
mechanical, you got mounting hole, and mounting hole pad.
Okay.
And
So-
That's what I'm talking about.
No, I was saying that rather than put them in the editor, have them put the mounting holes so they appear on the schematic, and
Right,
not just
yeah.
post them across,
Yeah,
you know. And then you can pick probably plated or non-plated, depending upon whether JL support. A lot of the low-end manufacturers used to not support non-plated holes. I don't know if they will.
yeah.
By the way, I have an answer to your how to see the PCB from the backside without doing 3D view. Select it all and hit the F button for flip.
Huh.
If you do Control A, F,
It flips back.
yeah, flips.
Oh,
Okay, you hear that? You flip the board, you hit, what is it?
Control A to select everything and then hit F.
Okay. I like it. Okay. Okay, now. All right, we're through this one. This is what the front and back leg on the circuit in project one looks like. Okay. So now, you really should run ERC. The problem with ERC is it's going to report, because the quality of our footprints varies, you're probably going to end up with, and we changed a lot of net class rules, which the footprints didn't recommend. You're going to probably see a lot of errors. But it's worth popping and checking and going through and making sure that there's nothing like, one you really don't want to see is missing trace or something like that.
Yeah, 7 warnings and 11 errors.
Yeah. So look through the errors, and you mainly see that they're like edge of board spacing errors and stuff. I can tell you that PCB way doesn't complain about it. So there's where we are. So you should look through them, make sure you try to understand what they are. And like I say, there's levels of severity. Okay. Now, here is a JLC's PCB own instructions on how to generate with KiCad. Okay, they have a version for 7, they have it for 8. I'm sure they'll have a version for version 9. So this is the one for 8, which is what we're using. And I'm not going to repeat all of that. Go to this website, it tells you everything. Now, this dirty little secret. If you just package up the Gerber files with the defaults that are in KiCad, it works. But you should check all of this, because there's probably some cool stuff that you should be, then they might have a little different. But I've never had to, I have, when it was in 7, I did very religiously look through this, make sure all the little buttons were pushed and everything. You'd find that 99% of them were, but there might be 1 or 2 that they changed. And like I say, when I just hit the defaults, I've never seen any problem because of it. But your mileage may vary. All right. Now, the next thing you should use is a Gerber viewer to look at your Gerbers. So let's go ahead and let's see if I think I could. Well, no, that's the end of the presentation. So for this. So now but don't go because we still got more.
So I have a quick question, sorry. So we're going to JLPCB. Any comment on, I thought that there was a plugin for JLPCB to kind of push everything, but
No.
it's just their library. They just have a library.
No, they don't. JLC doesn't.
PCB what it has.
PCB Way does. But like I say, I like JLC better than I do PCB Way. Okay? So that's just,
Yeah,
you know, where you want to have it
cost-wise,
built. Okay?
cost-wise,
Yeah, for us, it's a no-brainer because it's much cheaper.
What about have you ever had them assemble anything? I know most of the stuff we do is probably through hole, and they don't like to, you know.
Okay. If I were working with a lot of ICs directly, not modules, ICs, then I would be placing and even with this, I did not do a very good job of placing bypass capacitors. And if you're doing bypass capacitors, surface mount bypass capacitors are so much nicer than the through hole body. They take a lot less space. But if you're doing it yourself, they're pain in the butt. So, I wouldn't be opposed to having them, pre-manufactured, but it's not necessarily cheap.
Well, if you use they give you the library, and if you use their libraries, and you're not having to do anything special, and if there's no through hole, then I think it gets to be, I've had them built something, they're relatively inexpensive, and you have to use your parts and through hole, then.
Yeah. So I think that's a good point, an honest point,
But you haven't had, I just want to wonder if you had
I just don't have a lot of experience.
anybody's.
So KiCad has its own Gerber viewer. Why would you use these other two?
Well, I actually like the JLC PCB one. Okay, they've actually added some things. What they'll say I can tell you because I've ran it last night, because they're going to tell you that the silkscreen font sizes are too small. Okay, but when I look at how they come out on here, I don't see any problems. So I don't know. I throw it out to you, but that's what it is. So anyway, so let's. I want to. I want to go to KiCad. I want to go to PCB. And you see where it says fabrication outputs? All right, so you want to click on that, on Gerber. All right, say, like I say, all of the, here's what the JLC will say. Well, here's what on this screen, you got to make sure you have these layers, you got to do and all these buttons need to be pushed. And like I say, the defaults are like mostly there. There might be one setting that's different. So you want to hit plot, then you want to hit generate drill files. And when you do the generate drill files, it's going to open up another box. And you're going to have to do a map, a drill map, and a drill file. So you're going to do all of that. Now, this is how you do it. I don't say do it. Oh, if you've done it.
Well, it won't because it wants to go to OneDrive.
Okay.
Your project.
Yeah, okay, so just close it. All right. Now, if you go to project 1 and look in the Gerber directory, you should see some files. I don't, but they're not on OneDrive because
They're there.
Okay. So now go here, go to JLC, PCB.com. Click on that. Okay. And you got to have your account. I'm going to, mine, I have an account.
You need Bitwarden.
Huh?
You need Bitwarden. Bitwarden fills in your passwords for you. It's great.
Yeah, I need to find the password. That's the one thing about my wife's old Mac machine that I really love is because since she's passed away and I don't know all her passwords, but she had them all in the password manager. So I mean, I do have a list of them. I can't look them up, but I don't have to use them day to day. So I mean, okay, gotcha. See if it'll let me in. Oh, okay. So this is when you log in. Let's see. I guess I've got this one. Okay. Wait a minute. What did I just push? No. I think this is the one. Okay, so now here you can click on the ad, and we want to go to oh, I don't have it in here. Does anybody else have an account with these guys? Anyway, let me see what we got here.
In answer to having JL PCB do assembly, I was just looking at something here. It says all those caps and resistors are for free if they are basic parts. Assembly would only cost about $10. This is for certain about.
Okay, well, that'd be good.
Yeah, that's,
Wow.
yeah, anybody's ever hand assembled circuits in it.
Yeah. So, I don't know whether it's fact or not. I'm just happened to scan through here and that was on the web.
No, that makes sense.
Wow.
Because, I mean, they got auto place and route, and if they got the resistors and capacitors in the tubes, and
If you use their parts, it's actually very reasonable to have them assembled.
yeah.
Somebody put a quarter in the TV. It's about to turn off.
Oops. Thank you, Ray.
Well, I must not have thought I downloaded it into somebody's computers, so it's not, I'll try this. Well, stick one of these guys in here and get here. Okay.
So anyway, if you look on the JL PCB site, you can go with, and they've got a library of parts.
Right.
And if you use their parts, then your assembly is really reasonable.
Yeah.
And they give you really good discount prices on a bunch of the parts.
And then that's what I was saying, they have they have a library for KiCad.
Yeah.
The JL PCB library, so if you design using their parts and their surface mount, then
Good. That's good points. Good, worth thinking about. Now, if you look at, so if you're in your Gerber directory, you should see this. You can see you have the individual files, and then you also have a Gerber.zip. Okay? So you want to, so you have to zip these. The Gerber zip is a zip of these guys. Otherwise, they want a zip file. So you have to zip up all your Gerber files. Then grab that, and you can see it's loading the files now. Okay, success. So they let it, this is what they think they're going to look at. All right, but what we want to do is hit over here, is hit the Gerber view. And so this is what it's going to look like. Okay, and if you hit the three, there might be other ways to do this, but if you hit the 3D, you can look at the back side and everything. Okay, so that's what it looks like. Now this is a new feature that I think they're putting in. It's a DFM check, which.
So are the traces just showing up on the backside?
They are there. They just, but if you look real carefully, but it's because the fill zones fill up so much area, you can't see them easily.
Oh, okay.
Okay. So we can check on this. Now I've used the other one, the free open source one. I've used that. I've downloaded that and used that before too, and it's a good Gerber view too. Okay, so here, Ray, you can see them a little easier here, I think, and you can do the DFM check. And here, so the way this works is that's the number of errors. The middle number is the warnings, and the third one is the OK. Okay. So this had sharp trace warning. And it turns out, so when you hit that, and you can look at them and see what they're really looking for is acute angles. Well, when you look at these, I think it's picking them up. What did I do? I want to say there was a way to have it highlighted on the board. Okay, there it is. So it's actually picking up something in
the 3.3 volt lettering.
and it's in the it's not in the copper. It's in the
Silk screen.
silk screen somewhere. And this one has, so this is unconnected things. And so you can click on that. I'm just saying is, I don't know if this is they said this is new and it might not be.
So looking at the Gerber for the top trace, and there are the 3.3 volt and 5 volt are in text on copper.
Okay, so there's an error. Okay, so hey, there's a good one.
and you can see from the color that it's in copper.
Yeah, okay.
I just pulled up a single layer and it's there.
Okay, so there's an error. And why 3.3 built would be in copper, since that whoever put it on there must have been messing around.
And
Anyway,
the important thing is, why didn't the DRC catch that?
well, how all those edge layers, edge patterns, which, I find it, they don't do what this one does. This
Right.
one shows you where it is. Okay? Where in KiCad, they just list you an error and it's kind of like, well, what does this error mean? Well, I wouldn't be surprised if this is part of the reason why you've got all those errors.
But that's not on the edge.
Well,
That's
but
in the
is
middle
it
of it.
edge to this edge? I mean, I don't know. I'm just trying to
Right.
say, I don't
Yeah.
know.
Yeah,
Okay,
what you have
so-
to do is you have to find that text, and then if you go in and look at that text, what you're gonna see is it's on the copper
Player,
layer
you got
versus
the silk screen.
Okay, but so what I'm saying is, thank you for finding that. So this is actually valuable. Okay, and so they would say these guys are not ready for production, not good. Okay, so
Unless you don't mind the net short.
go along with detail. Okay, okay, so here's a bunch of blanks. Let's see what those are for. Okay, it's saying that is in through hole pad annual. 26 of them. That sounds like the footprint on one module might not be right. Could happen. I don't know if this is, I don't know what that is. Look on the second one. I don't know what that is either.
Looks like the vias
Yeah, looks like they might be.
defined as something that JLC PCB doesn't like.
So anyway, here you go. This is a free tool, checks out some stuff. And here on the silk screen, it just totally hates the silk screen. Okay, it just hates it. And now exactly why?
That's interesting.
It looks like there's little blibbons. Just little, I suspect that's a dot. I suspect it's like maybe a 3.3 or something like that. That's how somehow the dot got separated from the rest of it. This is something you have to be, when you're dragging the footprints around from that initial big block that you got, it's very easy when you select to miss one of the silk screen layers, silk screen tab. So you end up with a silk screen over here and a footprint over here. Now, when you highlight the part, you'll see a blue line through that part and you can move it back over. But it's easy to get, when you're moving parts around, to not select the whole footprint. So that's a thing you want. But anyway, so this says needs some work. Okay. Now, that's what we wanted to find out. But let's say, who cares about all that crap? Let's go for it. Okay. You can see the cost is $2 for the PC board. And if you check on their, somewhere there should be, here it is. They always have DHL send it to you, which is a reasonable price, but it's $17. And you can, if you're willing to wait, you can get it for $1.50. Oh, wait a minute. Whoa. Yeah, $1.50.
$1.50, yeah.
Yeah. So,
And then there's 30 cents tax.
yeah. So my thought on that is,
You think they're paying that to Texas?
Yeah. Who cares?
but the whole point I'm getting at, would this be a workable PC if you really just said screw it and send it? Probably. But you know some errors that are easy to fix, go do it. You know what I mean? Now you've got to admit I have to figure out why we got a 3.3 and a 5 volt in copper. That really suggests that some guy putting this together screwed up. Because that is not going to happen in KiCad.
So it's
Okay,
I'm looking at it in the 3.3 volts. It's that tech copper wire.
okay, so can you just switch it over just for Jim?
Yeah.
Okay. So now you'd have to rerun the Gerbers and how to do it. Okay. I think we have fulfilled our mission. You guys have seen it all, and probably more than you wanted to see. But with this presentation, I think you can guide yourself fairly well through a KiCad design. Okay? And we did put together a non-trivial board. It's not, the classic resistor, LED, and a battery. We went a little further than that. So that's it, guys.
Yay! Thank you, John.
Thank you.
Awesome.